All right, in this video, we're talking about linear modeling. So I'm going to use a linear function to help me predict what future outcomes of a real-world situation might be. All right, real-world data is not always perfect, so it's not going to follow a perfect straight line. However, it could follow a line very, very closely. Therefore, I could use a linear function to model that data. Now, if we'll look here, so we talk about the volume of gas at a constant temperature is linearly dependent, right? So they're telling me right there it's a linear function. So what I'm going to look at is how is the volume of hydrogen gas, how is that affected at temperature, okay? So it says on part A there, we're going to write a function v of t, right? So I know v is going to be my y value. So I know I want v equals some slope of t plus b. I know in the end this is where I want to get, and that's part A. So the first thing I need is I need a slope. And so I know that slope is m equals delta y over delta x. And if you'll notice, I have a whole bunch of points to choose from. I have 1, 2, 3, 4, 5, 6, 7 possibilities. You can choose any two that you want, all right? I'm going to choose these two right here in the middle. And I'm going to write those coordinates down, right? So I know the coordinates are 0 and 22.43 and 20 and 24.08, right? So as I start from 22.43 and I move to 24.08, I know that is going to be 1.65 over, when I go from 0 to 20, that is going to be 20, so I have this. Now, you could leave it as this fraction, or you could go ahead and get the decimal, which I'm going to do. It's 0.0825. So now I know my slope is going to be this 0.0825 right here. Okay? So now I need to plug that back into my equation. Now, the other thing you can consider is, look, I got a point right here, right? If I have a point and I have a slope, I can plug that into point slope form, which I'm going to do right now. V minus 24.08 equals m, which I know now is my 0.0825. times t minus 20, and there we have an equation, right? It doesn't tell us which equation to put it into, right? Most of the time people will put it into this, but to do that, all you got to do is distribute and then add the 24.08 to both sides, and you'll have your slope-intercept form, okay? Another thing you could have done is you could have noticed, well, look at that point right there. What do we know about that point? Well, I know the t value is 0. If the t value is 0, it's also our independent variable here, which is our x. What's our y value? It's 22.43. So what you could do is you could skip this part altogether, and you could just jump straight to, I know what my intercept is, and that's v equals 0.0825 t plus 22.43. So those are our two possibilities there, and if you go ahead and simplify this and solve this for v, you're going to get a number that's very close to that. And like I said before, our data is not perfect, so neither will our equations be. Okay? All right, so part B down here says, what is the x-intercept of your line? Okay, well, if I'm on the x-axis, I didn't go up or down, which means my y value has to be 0, right? So I'm looking for that x-intercept. I know my y value is 0. So what I'm going to do is I'm going to use my original equation of v equals 0.0825 t plus 22.43. And so now I'm going to take this 0, I'm going to plug it in for my v, right? So I have 0 equals 0.0825 t plus 22.43. I'm going to minus 22.43 over to the other side equals 0.0825. T divided by 0.0825. And I'm going to find out that t equals negative 271.8. All right, so now that is my x-intercept is negative 271.8 right there. Okay, now your answer may vary just a little bit depending on which 2 points you used originally up here to find your function. So as long as you are a number that is really close to that, you're good. Okay? All right. A couple things to remember. Linear modeling is not always going to be perfect, so your answers may be be slightly different from someone around you. So as long as you're close, you're good. And choose any 2 points to start your process. Hope this video helps. See you in the next one.